Hello. We like to take some time to go over how to find the derivative at point A for a function like this. It's a rational function. And to find the derivative using this formula, we're going to step by step. Okay, so f of x is defined as such, and f of a is 2 times a plus 1 over a plus 3. F of a plus h, basically everywhere x will be replaced by a plus h. So we're going to do that substitution over here and over there. Okay, you can reorganize it. Okay, you can reorganize it. For example, on the top, I can write it as 2 times a plus 2 times h, 2 times h plus 1. Hold on. Plus 1. The denominator will be a plus h plus 3. You can reorganize it by moving this piece to behind it. Then you say, why do you do that? Okay. It's optional to do this, but considering the fact that we have f of a like that, there might be some convenience that we can, we can take advantage of. Okay, so that's what we got for f of a plus h. Okay, but you can stay the way it was. Okay, you don't have to do, once again, you don't have to do what I do. Follow me. If you want to do it your way, pause and do your way and come back, we compare notes. And next we're going to do f of a plus h, subtracting f of a. Okay, and we're also going to divide by h. All right, so be careful about alignment. Okay, so this equal sign and the fraction bar are on the same level. So this whole thing is the denominator. Oh, sorry, this is, I'm just going to use one of it. All right. All right, so this is f of a plus h subtracting f of a. Okay, so that's f of a plus h, which is right here, right? And subtracting f of a. So we have set it up. You can treat it as complex fraction, or you can also write it this way. 1 over h multiply the whole of the numerator, that you can write it this way. Okay, or you can use parentheses, doesn't matter, same thing. Okay, same thing, but you must have a parentheses or brackets. So this part must be enclosed in a parentheses or bracket. And the other way, of course, we're going to treat it as a complex fraction. Okay, if we treat it as a complex fraction, maybe I can show you in 2 different ways so you can see a comparison. Okay, so if you do it this way, as a complex fraction, you get something like this. If you treat it the other way, right, some of you like to do that, and you work with this piece, you work with that piece, and we should get the same answer. Okay, so we're going to do a comparative study. So in the complex fraction case, and you're going to multiply, right? The common denominator is a plus 3 plus h. Multiply a plus 3. They should be in parentheses, okay? So numerator is the same as the denominator, right? And you know the drill. And we're gonna take this piece to multiply with the denominator here, right? We're gonna take that piece to multiply the numerator on the top. So you multiply with that one, you multiply with that one, okay? And then we're gonna do some reducing. So this piece will reduce with that one, and a plus 3 will reduce with a plus 3 here. So now you can see you will have this term left, but you must have this in parentheses. Over here, 2a plus 1 will be in front of the other factor. So you have multiplication of 2 parentheses on the top and bottom. Let's check out the other way. The other way, you're going to have to make a common denominator. So this piece, we're missing a plus 3. So that's a plus 3 over a plus 3. On that piece, we're missing a plus 3 plus h, right? So we multiply by 1. So we make the common denominator. Boom. All right. And next, we have the same denominator. We're going to take a numerator times the numerator. Okay, so write one more line. Write one more line. So this piece will multiply with that piece. That's denominator times denominator, numerator times the numerator. So a plus 3 will multiply 2a plus 1 plus 2h multiply a plus 3. So a plus 3 will go there. All right. And the same is with the second part. You get a plus 3 times a plus 3 plus h. We got a common denominator. And numerator times the numerator. So, and there's a subtraction in front of it. So we're going to combine these two, right? So subtracting numerator times numerator. There. So that way we got here. And these two are the same. The only difference is that you can see they have the same numerator. They have the same denominator. The only difference is that the denominator, one of the factor h, get moved, get to be isolated in the front. And you can certainly move it together. You can move them together. Okay? So you can put the h right there. All right? So by this time, you can do either way. And next is how do we handle this numerator? How do we handle that numerator? So there are many ways you can do it. The most common way that most of you, I imagine you will do is to it's the FOIL, right? A plus 3 FOIL, 2a plus 1 plus 2h, you're going to get 6 terms. Over here, you're going to get another 6 terms. You got a total of 12 terms, and then you're going to combine the like terms. Okay? You're going to get a simplified form. But I'm going to do slightly differently. I'm going to show it to you how I would do it. Okay, so I'm going to think out aloud. So this is my watch paper. Okay, you can do your way. I don't mind. Okay, but I'm going to show you some different way. You want to get better on your algebra, right? You want to keep things simple. Okay, there's a way to keep it simple. I treat 2a plus 1 as one entity. So 2a plus 1 is one entity. Do you see that? 2a plus 1 as one entity. A plus 3, I would treat it as one entity. Maybe I will put something like that. Okay? Just one entity there. So instead of getting 6 terms on the product, I'm going to just take this as one piece to multiply the rectangle and then multiply to h. Okay, so this is what I got. I take a plus 3 times 2a plus 1. So 2a plus 1 multiply a plus 3. So I don't completely multiply this out. A plus 3, sorry, a plus 3. Plus, okay, a plus 3 times that, and a plus 3 times 2h. So I got 2h multiply a plus 3. So I'm done with the first term. So I got 2 big terms. Subtracting, I would do 2a plus 1 times a plus 3. So 2a plus 1, 2a plus 1, multiply a plus 3, multiply a plus 3. Oops. A plus 3, right? Lowercase. We'll take this box to multiply a plus 3 and then to multiply h. So we get another subtraction of 2a plus 1 times h. So h times 2a plus 1. See now see what we got. This piece and that piece are opposite. So we got 0. So that this term and that term, they're gone. We only have these 2 left. We only have these 2 left. That's one way to do it, okay? And you get a simpler form. You get a simpler form, okay? So either one of this you work with, the next part, the next step, right? I will get the numerator is going to be that. Hold on. I will keep the denominator, right? And I put the whole of that, I'll put the whole of these in place to show it to my reader. And surely my reader can read this piece and that piece are opposite. So the next step, I will have these 2 are removed. Okay? All right. When you do algebra, you try to get it easier, simple, and not make too many mistakes. Okay? And the way to do algebra is usually not unique. I'm not insisting that you have to do it my way, but I will show you a simpler way, okay, how to see it. Okay, so now the denominator stayed the same. The numerator, you see that in the numerator, I can factor out an h. I can factor out an h, right? So inside, this is going to be 2 times a plus 3. Oops. Subtracting. Whoops. Subtracting 2a plus 1. Okay? Yes, you can do the algebra this way. Just keep it simple. Keep things as simple as possible and make it easier for you to check. Now, of course, h and h will be reduced. Inside the parentheses, we're going to open up the bracket. So 2a plus 6, right? Minus 2a minus 1. So minus 1. All right. Now what we got? We got 5 on the top. We got 5 on the top. We got 5 on the top. So if you do it any other way, no problem. You should get a 5h before the h was reduced. All right. So I hope that this way at least give you some ideas. Maybe we can do algebra a little bit differently and make it easier for us to check. But anyway, but you can still do the way you like to do. Okay. I'm not insisting on you do it my way. Okay. Now, finally, we're going to take limit. And this time, right, f of this ratio becomes that. So that's going to replace the whole thing. And direct substitution as h approaching 0. So we got this, right? H is 0. And 0 plus 0 is a plus 3. A plus 3 times a plus 3, that's a plus 3 squared. And you're done. You're done. Okay. If you do the other FOILs, no problem. Once again, do not worry. Okay. I do not insist on you do things my way at all. Never. Okay. Do it your way, but learn something new. Learn something new. Okay. Since everybody wanted to be easier and simpler, and there's a way to do it. But anyway, thank you for watching.